Alright folks, welcome to this introduction video on the concepts for our lesson 11. I hope that this helps you get your mind around what's happening and maybe a refresher for you. So let me cut the video off and get right at it. Okay, so if you notice here on our introduction, we want to talk about linear functions. A lot of functions that we see in life can be modeled mathematically. A lot of phenomena can be modeled mathematically on a lot of different fields, business, science, so forth. So we're talking about the most basic, fundamental function would be a linear function. Of course, we see line here, so we know what's going on there. Now, here are a couple examples of the concept and why it's important. This first linear equation is an equation in two variables, h and p. This stands for hours that you're working a week, and p stands for your pay. We're all very excited about that. Now, what does this function say? Well, in this case, p is in terms of h, the hours. So the more hours I work, the more money I make. So we understand that. Now, what is the meaning of 0 hours? The meaning of 0 hours is that I will get $100 if I don't work any hours. Now, this is obviously a job on commission. Maybe it's a waitress, right? Okay, or a waiter, $5 an hour. But they're employed, they'll give them $100 a week, okay? So H stands for the amount of hours I'm putting in a week. What if I put 10 hours in a week? That's 50 plus 100, or 150. So you could think of the H as some type of independent variable that has a certain amount of domain, right? I mean, I can't work any less than 0, and I can't work any more than, I need my sleep and take care of things. So, and the business is only open up so many hours a day. And so this is a generalized form of a linear function, which I think you should be able to make sense of. Now, the second one here is another one that may be of interest to you, your GPA, or your grade in the class. A lot of people are doing well in the class, and that's a very good thing. But here in this case here, we have G equals 3.1H plus 50. Let me kind of lower the music down here. All right, so what's happening here is this is saying if I put no time in per week, I would have a 50 average. Of course, a 50 average is not going to do us a whole lot of good. But for every hour I put in a week, my grade's going up 3.1 percentage units. So, see, that's a very good situation here. And now, we could do a study and see what this actual number is, but for the sake of our presentation here, we're just getting the gist of what's happening. So this is my grade. I want a 90. Can you tell me how many hours a week I would have to put into the class? That's a very good question right there. Also, H has a certain domain from 0 to a certain amount of hours I could possibly put in the class. So what we're talking about in this particular case is some general idea of what makes a linear function, or what is a linear function about. So I hope that helps you. Now I want to talk about something that's a lot of fun. Matter of fact, it's called rise over run. And we're talking about slope here. Now let's focus in on what I call the basic coordinate plane. Slope and the basic coordinate plane. Now we could recognize that this is a 10, 10, 10, 10 screen. Let me turn it this way here, okay? So this is our palette, if we would, on how the graph is presented, our graph paper, our plane is presented to us, and that is something we're all familiar with. Now what I want to do is I want to blow that up a little bit, and I want to talk about slope. Okay? The slope of a line is its slant or its angle. So notice this brown line. The brown line, its slope is going up. Think about you're in a car and you're in a car, you're going up a hill. That would be a positive slope. This would be a negative slope. Now, what slope would this be? Well, my tires are not going anywhere. A tire is round, okay? Zero slope. Okay, so keep that in mind. So a horizontal line is a zero slope line. Think about that, okay? Now, how about this line right here? This is strange. This is, if I have a car going that way, I'm going to crash, and I will not be having a good time. I will call that undefined. A vertical line has an undefined slope. That may be helpful. Now let's actually talk about the values here. So what is the value of this slope? Well, just remember the saying, slope is fun, it's rise over run. Here and here. So between the left one and the right one, I went up 1 to the right 2. That would be a slope of 1 over 2 or 1/2. How about here? What's the slope? Well, if I identify that intersection and that intersection, I'm going up 2 to the right 1, or that's a slope of 2. All right, can I go kind of different? Sure. Here, what's the slope of this line? Well, it's negative. You're exactly right. From here to here, I'm going down 2 to the right 3. So that's a slope of negative 2/3. This is the idea of slope. So keep that in mind. Positives, vertical undefined, negatives, and zero. That is very, very important because slope is used to describe rate of change. Now what we need to do is let's, of course I just mentioned vertical and horizontal lines. So again, vertical lines go this way, horizontal lines go this way. Slope is fun, it's rise over run. There's no change, there's no rise, so it would be 0 over some number or 0. Here, rise over run, the rise is a value, but the run, it's not going to the left or the right. The bottom would be 0 or undefined. That is the gist of a vertical or horizontal line. Now, one thing we need to understand, horizontal lines have the equation y equals b. Vertical lines have the equation x equals a. I probably should explain that, so let's do this. The question is, what is the equation of this line? Well, the y value is 2 here, 2 here, 2 here, 2 here. That is the equation of that line is y equals 2. What is the equation of this line? Well, what is x right here? X is negative 4. What's x everywhere? X is negative 4. Okay, so hopefully that helps you out. Okay, I notice my time's going on. There's no way I'm going to get all these things in this time, so we'll have to break this into a couple videos, a part 1 and a part 2. All right, number next. It's important for us to recognize the different formulas for a linear function. The one that we're all familiar with is y equals mx plus b. This is called slope-intercept. That stands for your slope, and this stands for your y-intercept. Another one that you may not be familiar with is point slope. Point slope. Now, I have just decided not to try to talk any faster, but to really emphasize explaining. So here you guys go right here. Point slope. Now, why is that called point slope? The reason why that's called point slope, if you had a point x1, y1, and you have slope m, hey, slope is just the change in the y, over the change in the x. If I had a point x1, y1, and then I have a general point on the line xy, the slope would have to be expressed this way. And if you plugged in numbers, it would be numerically that way. Notice what happens if you take this equation right here and multiply both sides by this value at the bottom. You would get y minus y1 is equal to m times x minus x1. Okay, if we multiplied this equation by that bottom expression. Notice that this expression matches the formula that is given. So that is helpful. And the last formula that we're talking about is the general formula. AX plus BY is equal to C. This is called general or standard formula. And again, A and B are integers. Some people like general formula. It doesn't have a lot of value to it, but it is a standard way of looking at a linear function. All of these three formulas are related to the independent and dependent value, and they all represent a function on the coordinate plane. All of the x's and y's for all different forms of the equation would work. So this is what I call the three formula review. Now, let's talk about, I want you to graph this line. Well, let's see, graph the line. Well, we could plug in some numbers. You know what? I'm going to use 2. If I plug in 2, I get 1/2 times 2, which is 1 minus 2. 1 minus 2, that's -1. Okay, I could graph that. Here's my plane. 1, 2, 3, 4. 1, 2, 1, 1, 2, 3, 4. And the value 2, -1 is right here. Okay. Now I could plug in a 0. That's a good point to pick. Remember, we're just, trying to figure that out here. Hold on a second. Okay. So now here, plug in a 0, we get 0 minus 2, which is -2. 0, -2 is right here. What would be a good, we could just stop there and, draw the line here, but it would be good to pick maybe another point. 3, 4 would be a good value to pick, because if I plug in 4, the 2 goes into the 4, 2. So 2 minus 2, 0. So 4, 0. Now, the important thing to keep in mind is, are you seeing that the points are in the same line? That is called collinear. So here we go. Here's my line. Now, the question is, what color is the coordinate plane? The coordinate plane in this case is red. What color is the background of the coordinate plane? That's white. What color is the function? Black. Okay? So we just graphed this linear function. How many points are on the line? Well, you may say 1, 2, 3, but you would be inaccurate. That line is made up of just a series of points. Is that right? Okay. I take any 2 points, I could put a point between them, a point between them, a point between them. And you may be saying, what's the point? I go, well, the point will become eventually a what? Line. So think about it that way. So we're talking about graphing a line.